Precisa da puta que
Qual?
não
Deve ser lá no Slack.
disto, não é? Este.
Isso não vamos ser. Já não sei como. Pá, não sei se aqui isso é o melhor sítio. Ou seja, por onde é que tu entraste?
Estamos ali por trás, nós viemos.
Esta maltinha logo aqui, é vivo.
Bem, mas o ecrã não se vai ver. Para ver, para lá. Não, não, já pode ir. Estou velho. Já dá para ver os slides. Olha, acabei de dizer que estou velho.
Para, não tem mais dois três. Satisfação? Então, pessoal, muito bem-vindos ao 12º Data Science Portugal Meetup. Incrível que vais estar em 22.
English.
Okay.
English.
You guys prefer in English? Because I can do in English as well. So welcome to the 22nd Data Science Portugal Meetup. Yeah, it's been 22 already. More than a year. Data Science Meetups. So 3 things I wanted to mention, and I'm going to mention them now because otherwise I'm going to forget. So first thing, everyone checked in already? There's a guy going around asking your name, that's Louis. Make sure, otherwise he's very data driven, so he needs to know. Okay, that's one. So the second one, oh yeah. At the end of this presentation, there's going to be a small quiz for you guys to give us feedback on how the meetup went, and we have a small prize. If you do participate, you might win a small prize. Right, that's correct. Not everyone will get a small prize, but someone will get that prize if you fill the questionnaire. Okay, it's very important for us to get this feedback to just keep improving these meetups. Third thing, there's a dinner. If someone wants to go to the dinner with the speakers and the organization, make sure you. Yeah. Oh, you want to go?
I'm not signed up, so I
all right. So talk to maybe some of these guys. That guy? Yes, talk to that guy, or just go to the doodle thing. There's on the platform. Anyway, let's get started. I don't think I forget. All right, there's one more thing. So this is a very informal environment. You guys feel free to to join in the conversation, interrupt the speakers, unless the speakers don't want to be interrupted. We should ask that first. But go ahead and let's do this both ways. All right, let's get started. So, to begin with, Data Science Portugal, this is where we are right now. You can find us on meetup.com, obviously, as you did. You can find us on Slack, Facebook, LinkedIn, Twitter. There's a GitHub as well with all the past presentations if you want to check them out. So please do. Just memorize this very quickly. Those numbers on the right are the people that are part of each of these groups, and they're always increasing. All right. So we are volunteers. So we do put in some of our money into this, but it's better when someone helps us. Right? So if you are part of a company that's interested in this field, in this area, do contact us to see if you want to become a sponsor. It will help us grow. There's a lot more things we could be doing if we had some sponsorship. These are the companies that have sponsored us in the past, right? And this slide is also one that keeps increasing at every meetup. All right. This particular event, the 22nd Data Science Portugal meetup, was sponsored by UbiWare, and the venue was kindly provided by Incubadora da Universidade de Aveiro. Right? Yes, this is Incubadora da Universidade de Aveiro, in case you don't know. All right. So the agenda for today, very quickly, it's going to be, we start at 7, perfect. And João Garcia will start with a presentation on smart cities and data science. So João Garcia is from UbiWare. All right. Then we'll take a group photo. It's 5 minutes. It usually takes much longer than 5 minutes. So we'll try to do that. And then we have the beer break. So there's actual beer there somewhere. And then Artur Pereira from the University of Aveiro will join us to talk about project. Then we'll close. We'll give you some time to fill in the questionnaire, award the prize, and then we go out to dinner. All right? Okay, so let's start with João Garcia from UbiWare, talk about smart cities and data science.
Okay, so hello everyone. As you might have seen, I'm João Garcia. I'm from UbiWare, and today I'm going to talk about data science in smart cities. First, I'd like to give you a bit of context about why I'm here talking to you. I'm from Coimbra. I did my master's in the University of Coimbra, and since then I've been working at UbiWare. There, my first work was developing a recommendation engine for the real estate market, and from there I've been working on smart cities ever since. As a data scientist, but I also contributed to the system architecture of our solutions, and also as a general software developer, among other things. UbiWare is a company founded in 2007. We have certain qualifications, we have the certifications, we have office in Aveiro, Coimbra, Porto, and Lisbon. And we've generated several spin-offs and are involved in some standardization initiatives and groups. These are our headquarters in Aveiro, our new building, and we are involved with several partners from throughout the world, Europe and Portugal. So UbiWare works mainly on 2 sectors. One is telecom and future internet, and things such as quality of service from ISPs or 5G networks. But as you probably guess, I'm more focused on the smart city area, and that's what we're going to talk about here today. So, what are smart cities? People have this idea of smart cities being like a futuristic environment, state-of-the-art technology, but it doesn't really have to be that. The goal of the smart cities is to create a smooth information process that can be used to build service upon it. So with this information, this data, it is possible to take not only informed decisions, but it's also important to evaluate the impact of these decisions on the city. So, as I said, the first step it's always to gather data, and some people might notice that this can be quite better quality of services, and for a room full of data enthusiasts, we can guess the endless opportunities we can create from this data. Uber in specific has its own horizontal platform that gathers data from various city domains and offers solutions upon it. As you can see, for smart parking, waste, air quality, and traffic, among others that we'll talk a bit more in a bit. Apart from this, it's important to notice that there are several important issues that need to be solved, and Uber is involved in several European research and development initiatives in the areas of data interoperability, open data, and big data. So, speaking a bit more about each domain that can be worked upon for smart cities, starting with mobility, for example, for parking. When I'm speaking here about parking, we can consider sensors that are located on the ground of parking spots or in the entries and the exits of parking garages that counts the number of cars coming in and out. And what can we do with that information? Apart from obviously having real-time context data on the parking status of the city, we can also make, for example, predictions upon this data. So we can, through historical data, understand how we can expect the occupancy of a parking area to be. And from there, we can understand, for example, how certain events can affect these areas, or how the weather affects these areas. And in that way, we can give the cities valuable services, because we are helping them improving their quality of their services and the quality of life of their citizens. Before going any further, it's important to notice that I will speak a lot of terms like predictions and stuff like that, but it's not important to understand what we can do with the data, but how useful it can be to the cities, obviously. So here another example is for traffic, where through sensors located on the ground, we can count the number of cars coming in or out of certain roads, or, for example, also getting their speed. That's more relevant. Another way of getting this information is through video camera feeds, where through computer vision we can understand the states of the road. Here again, we can do sort of predictions and observe the occupancy or the traffic, in this case, of certain roads, give the city access to the service, and also, similar to parking, understand how certain events can affect the city roads, and as such take action upon it. So they offer a city a service to improve the efficiency of the roads. Now, on a more different domain in the environment, we have a solution that is the waste management, where either through sensors that can detect the amount of waste the container has, or through information given by the waste management employees when they pass through a waste container, it is possible to understand which containers are full or need to be picked up. In that case, we can offer efficient waste collection routes to the waste trucks and improve the efficiency of waste management services. It is also important to notice that it's not always feasible to have sensors in every waste container, because they can be quite expensive. So data can be used to actually understand how each container in each area is filled up and in which days it is important to be picked up. Another service related to the environment is the air quality, where through air monitoring stations it is possible to have an idea of the air quality throughout the city, and as such it's impossible to understand the patterns or the tendencies of the air quality in certain areas and take action upon it. Going now to a different area. This one is for water, where through smart meters, which can take measurements of the water being consumed in the household or even in specific taps like the shower or the kitchen, it is possible to understand water consumption within a home. And there are certain use cases that can be built upon this. For example, one we are exploring is the detection of water leakages. So through the measurements from these smart meters, it's possible to understand quite early if a home has a water leakage and warn the municipality to go and fix it. Another, still in the water domain, there are other systems such as the water management systems of the city can provide measurements to, for example, understand when a flood is going to happen and have an early warning and the possibility to prevent or take measurements to diminish the damages. The lamppost is quite a different scenario. It's one that's appearing now in European projects, in which you have a modular lamppost where you can collocate various modules, such as, for example, video cameras, air quality stations, even 5G network routers, so that it's possible to have, well, the main goal of this is to bring the logic to the edge of the network. So in a normal case, the data that is being picked up by the sensors is sent to the cloud to be processed. In this case, things that can be done locally are done there. An example of this is, for example, if you have video cameras, you can process the image there, and, for example, for use case of surveillance or detecting the amount of traffic or the parking situation, can be done locally, and you save a lot of cost in transmitting this data to the cloud. And then you can take local action, for example, by detecting that there is a lot of traffic. You can change the lights to improve the efficiency of the roads. And there are other domains. For example, in tourism, if you have the location of the tourists and the information regarding the attendance of certain tourist attractions, it's possible to recommend to tourists based on their location, their past locations, their preferences, new attractive locations to visit. And I've been talking here a lot about each specific domain, but it's important to notice that for a city, it's not so important to have each of these specific domains, but actually crossing the data to understand the impacts that certain elements have on others. So if we don't have that, it's impossible for the city to really understand the impact of their decisions, and as such, it's not really valuable to the city to have these services if this doesn't happen. And this is an actual problem that we are working in. We can see here that being such an innovative area, it also has its problems. So it's not very mature. Even in the Facebook posts for this meetup, there are people complaining that in Lisbon they supposedly are a smart city and have data sets, but they were complaining that those data sets were garbage, because since it's such a new thing, people just want to say they do things in this area and they post data that is meaningless for whoever wants to make anything with it, build service upon it. So, and to add to that, there's also a lack of interoperability, because every every company makes their own product, every city makes things their own way, and it's hard to interconnect the various services of these areas. And as I said here, cities can be very big and complex, and it's really hard to offer them meaningful services quickly. So this is, you have to know that this is a work in progress, and you have to take a long-term look at the situation. So what actually needs to happen now is we need to take the next step. So right now we have cities locating sensors and gathering data, and we need this to be a permanent situation so that you can obtain a lot of data. And upon that, we can build services, being data science or whatever, without wanting to be very generalist here. We need to start building this service to provide cities with this valuable service. So now I've talked a lot on general terms and giving you a big overview of this area. So I'd like to share a bit of my experience in working on some projects. Thank you. Working on some projects in this area. So this is LivingX was as I said before, was the first project I worked at Jubiware, where the challenge was to build a recommendation system to recommend homes to citizens in Lisbon. And the main goal here is to focus on the neighborhood data. So when you are picking a home to live in, it's maybe as important as the typology of the home, also know the neighborhood. So this includes the services the neighborhood has, even things you can obtain from sensors such as air quality or traffic or criminality. All that type of information can be important when choosing a home, and that's where we wanted to focus. So this we had a lot of different types of data. So apart from having user data, which comes from their preferences and their interactions with the platforms, and also their social network information, we also have this home information, so the location of the homes and their contacts, and also have city data, which includes, as I've already said, service and stuff like that. And this created a very complex system, if you can say so. In this case, I opted for a hybrid approach, in that some of you might have heard of the cold start problem, but basically, if you want to recommend things to users based on what other users have already experienced, it's a very effective way of recommending, but in the beginning, you have zero information about the user's interaction, so you can't start the whole system without the user data. So you have the hybrid approach mixes this system with a system that's based on preferences that were explicitly given by the users. So what kind of service they like, what type of home they want. And so that's the hybrid approach. But the system involved a lot more than that. For example, here in the image, you see the blue blobs that are neighborhoods computed by the recommender system, where the goal was to create regions where that were uniform, so they had the same type of services and criminality, so that we can actually relate the user to a specific area. And this was done by a genetic algorithm that tried to maximize the uniformity of each area. Apart from that, we have already said, we have the average approach that uses collaborative filtering to recommend homes to users based on other users' preferences that are similar to it, and also on the user explicit preferences. And in addition to that, we also had a community computation algorithm that I think if I remember correctly, it was called Big Clan, that through Facebook groups and connections created community of users. So when recommending, we can also give more value to areas where there are a lot of, or at least one community of user. As you can see, this can be quite a complex thing to build, and the lesson I learned from this project is sometimes when you have so many components, it's important to be able to test each one individually. So when I got to the end, I designed the system, I developed it, and then I had like a big monster where I have a lot of nodes which I had to turn to actually improve the efficiency of the recommendation, and that was a very big headache. So that's the biggest lesson I got from building this system. So another interesting experience I had was for a project we did for the city of Porto, where they had some smart meters in the houses of the city, and the goal was to detect water leakages. They had a system that was very simple, and in some cases it could take a long time to detect these leakages, and it could lead to a lot of water wasted. So this was kind of a humbling experience to me, because when I got to this project, I was very excited because now I had a really big data set that I could work with, and I wanted to try all the methods I've been dreaming of applying to this kind of data set. So this was a time series data, so I started by trying to apply the time series algorithms. In the end, I tried the Sarima, if I remember correctly, but that really didn't fit the problem, because while we had readings that were very predictable, so for a home that wake up at 8, that they take showers and then they go to work and it stays at 0, then they come back and they cook and whatever, it was very easy to see the pattern, but not everything was like that. So you have they could not even be homes. They could be like event places where you had like for 6 months always a 0, and suddenly they were like at 1,000, stuff like that. And I wanted the system to be able to cope with all these kinds of situations. So I tried a more generic approach with algorithms such as gradient boosting machines and stuff like that, but still it was hard, because these algorithms didn't take into account that the reading of 0 is very important to this case, because it indicates that at this time there was no consumption, obviously, so it basically 0 liters for an hour, and to detect that there are water leakages, it's generally because they never reach 0. So that's why I had this kind of humbling experience, because in the end the simplest algorithm worked the best. So the actual work, the work that actually gave value to this solution was not experimenting with all these methods, but was also actually analyzing the data, understand what features are actually important to detect water leakages, and then just apply a simple mathematical function to understand when these features leave the pattern and actually indicate that there is a water leakage. So that's the lesson I learned from here. So you have to start at the beginning, so by analyzing the data, and you have to value that kind of work, because in the end it can be very important to the methods you choose to apply.
Can I ask a question? In this household data, is this like census data, or you have to choose some kind of sample data? Or
no, it's a smart meter that for every hour it counts the water consumption at the household. So
yes, but the question is Yeah, I understood that. But do you cover every household in Oporto, or
No,
is
no,
it a
no,
sample?
no, no, no.
Who defines that? Who defines that?
It's the city of Porto that has to install these sensors. In this case,
For the ones installed, you process all of them?
yes, yes, yes.
Are they anonymized, the data?
Yes. At least the data that reaches is, yes.
How many cases? Do we have an idea for first? Thousand.
It was more than that, not a lot more, but I actually worked on this more than a year ago, so I'm not actually sure, but it was around 2,000, I think.
2,000?
So in the end, you could, for the time span that the sensors were active, we had like 21 million readings, hourly readings from this audit. I reached the end of my presentation. As you can see, there are a lot of things that you can do in this in smart cities, and a lot of possibilities, but there are a lot of things actually that need to be done. We at UVware are trying to follow a minimum value product approach, where we are taking this step by step. So we are building products that fill the needs of some users, and trying to, for those products to be very robust and build upon that, so that in the end we can reach fully connected smart city. So what needs to happen, as I've said before, is we need to take the next step, to start building robust products over this data, so that cities start to accept this new paradigm and start to invest in these services, which improve the quality of life of the citizens, and also the quality and the efficiency of their services. That's it. Have any more questions?
I really like your project of the Living X thing. You mentioned efficiency and how accurate your model was. How were you able to validate your model? I mean,
Yes.
Did you use real like inquiries to people who purchased houses and were recommended by the system,
Yes.
or did you do an evaluation?
In this case, that's a good question. In this case, the project didn't really advance that much, but for business reasons, not really problem of the platform. At the time, we evaluated with a test group of users. I think at the time they were like 30 or something. I don't really remember. And we have evaluated the system to their opinion. So. Okay.
Any more questions? I have a question. I like this. This is interesting. Why do you use genetic algorithms? I want to know more about that.
So, firstly, it's because I really know them well, and they really fit the problem, because it's the way the genetic algorithms work fit the solution of starting with a random. Yes, and working on it to reach the goal, and maximizing the thing that was most interesting was how it reached that goal. So we could apply various formulas. So not only shifting like the centers of each area, but actually detecting when they were to be to split them, or in the other way join them. The truth is that for exploring the methods, I didn't explore that much, because these really fit well with the problem, and since I already knew them pretty well, we decided to go for it.
Do you think it works better than a grid search, for instance? Or is that not?
the yes, because the algorithm fit well with the not really the data, but the type of data we had. So it's the advantage of the genetic algorithms is that they are very flexible in the way that you can manipulate them into reaching your goal. And at the time, it was it fitted really well. I did them well, and the results in that case were good. So
Interesting. I will try that. Just one more question about the system. Is this something you built yourself, or are you using some tool that's available?
I mean, it never left the prototype phase. It was done with Java. The algorithm, genetic algorithm, I implemented myself. The rest were some. I don't remember exactly which libraries, but there were some external libraries.
In Java?
Yes. From then, I've been always working with Python, but at the time, since it was what I was most familiar with,
You found the light.
yes.
Does anyone have any more questions?
Question. So who actually owns this data? Is it the city or?
Okay. The data was either open by the city, so the portal for data, I think that's the name, has several data regarding criminality and those type of statistics. The data regarding the homes were from a web crawler to real estate websites. Trying to remember more. There was still some web crawling, for example, for events. There was I don't remember the name of the site, but this one has a specific site for all the events in the city, so they will take it from there. So mostly was what was freely available.
What about the data from sensors, from the water and the electricity?
At the time, it wasn't built with the sensors weren't included in the solution.
For the other projects, the water management.
Oh, okay. So that depends on the city. For example, this one, they're from Porto. We have also from our dev pilots in several cities in Portugal, Aveiro, Porto also, and Torres Vedras. Don't remember any more specific. And we also work with cities outside of Portugal. For example, Santander is the most smart city, which makes this there's sensor data available. So it comes from partnerships that we do with the cities. So these we have to work closely with the cities so that they can provide us with that sensor data. Okay.
Anyone have any more questions? We'll have some time. All right, so let's thank João for Should we move on to the group photo? Yeah. That's the next thing on the agenda. How we're going to do it. Oh, wait. You have to go there and change. No, you have to go there and change. And so how we're going to do it? Okay, so let's everybody stand up and just go to the corner, like
Só que o fator.
Estás a ser ouvido. Nós estamos a ser ouvido.
Você disse que alguns são teus. Não se senta que não é possível.
Estamos a live stream.
Eu não. Qual vocês são muitos, meu? Não tem nada para fazer. Falem todos no máximo. Ô, bem, antes do prazo, deixa eu respirar.
Obrigada.
Volta só para o possível.
Então é, tens de dizer uma frase qualquer sobre o teu texto para a malta seguir.
Um pouco na...
E eu repito e não vale. Pronto? Pronto?
Exato. Grande Menezes. Acho que expressa bem.
No data.
É para ver.
Tá bom. Cuidado aí, cuidado aí.
Eu acho que Eles estão na janela ao meu lado.
Qual é o sinal que você vai fazer mais? Qual é o sinal que
Se usarmos mais ainda depressa.
tem a missão?
Essa cada vez faz parte disso.
A zona B está organizada em unidades, unidades de eficiência e unidades de educação. Departamento, unidade de eficiência. Nós, sempre somos regulados. Os departamentos
O streaming ainda funciona? Sim.
There's more seats on the front if you guys want. Yeah. Are you afraid? So this has been the longest networking beer I've ever seen. Networking break. And then I had time to drink like 4 beers, so past my bedtime. So with us is Artur Pereira from IETA and the University of Aveiro. He will be talking about intelligent robotics and intelligent systems.
This is the
that's the last one.
I'm talking about this project.
Okay. Project Kobo.
Yeah.
All right. Yes.
Thank you, everyone. Okay, my name is Artur. I think half of you already know me. Well, I'm Mario. Is not there. No, he's there. Asked me to make an informal talk about one of my projects. So I just prepared 7, 8 slides for this. So I hope it's enough. The idea is to discuss what is related with this kind of project. I bring the car with me, the robot that is related with this project. And the idea is to, but before talking in the project itself, let me introduce where I belong to. So I'm part of the IRIS lab, which is the robotics lab from IETA, that belongs, of course, to the University of Aveiro. We have several projects related mostly with mobile robotics, autonomous mobile robotics, but also some other projects that are related with intelligent robots, for instance, intelligent manipulators, and so on. Here I put some of the não funciona. Okay, so I put here a number of the projects we are involved in the lab. Our main project is the robotics soccer team, Cambada. I think most of you already know about that project. We participate in several international competitions on that. We are nowadays involved in an important project related with intelligent manipulation. The idea is to have a manipulator, an arm, on top of a mobile robot that feeds machine in a real environment, a real factory. That we also have some projects involving autonomous driving. There is an autonomous driving project involving real cars that it is led by Peter Santos from the Department of Mechanics, and they are a kind of autonomous driving challenge related with this small car, the one I'm talking about today. We also have in the past worked with service robots. We have participated in the RoboCup@Home. It's a competition where supposed to develop a robot that do some kind of work in a home. For instance, identify objects, pick up objects, talk with people, etc. And also, of course, all of this involves human-robot interaction and have some kind of process in this matter. Well, we are involved in a number of robotic competitions. The more important ones is RoboCup. We participate in soccer MSL League, Middleside League, where Cambada team participates. We also have participated in RoboAtom, in 3D Simulation League. We have in the past participated in the Rescue Simulation League. Okay, we often participate in the Robotics Portuguese Open, Robotica, Festival Nacional de Robótica, where there is also the European Championship of the Soccer League. There is an autonomous driving competition, the one I'm talking about today. There is a rescue league, a factory, freebots, different leagues. Also, we participate there not only as a competitor, but also as an organizer. For instance, this year I'm the organizing of the autonomous driving competition, so if you want to participate, I can explain everything in competition. Okay, and also we organize since 1985 the micro hard context where we have a robotic competition for our students mainly, but not only. Okay, well, in terms of the project I bring here, in the Portuguese Robotic Open, there is this league called Autonomous Driving Competition, and the idea is to develop an autonomous vehicle that is capable of solve a set of challenges in a scenario that is similar to a real world. Okay, this is the scenario for this year competition. It was the same as last year. We have a track with two driving lanes. The width of each driving lane is around 70-80 centimeters. Okay, so there is a gantry in between where there is traffic signs. So there is a monitor displaying traffic signs, and the car has to follow the orders that are given by that traffic sign. For instance, if the sign is red, like it's there in the picture, the car has to stop at the crosswalk. If it is a green in front sign, it has to go ahead. It has to turn left or turn right, depending on the direction the robot is taking. In the middle of the lanes can appear some obstacles, green box there, and so the car has to identify it and overtake it in order to complete the lap. Okay. There is also some places where to park. There is a lane on the right side of the driving lanes where the car has to park parallel to the lane, and also there is some bay parks to places where the car has to park in some situations. That places can be empty, like in the picture, but one of them can be with a car there, or a box simulating a car, and so the car has to identify that which one of the places is empty and then park there. That's the main idea. Okay, since 2015, the rule changed a little from what it was before, and we split the competition in different challenges. Means that the teams that compete has to face different kind of challenges. It can choose which one of them to take. There are driving challenges. What the idea is to complete 2 laps. I think I don't know if I have. Yes, I have a slide for that. I'm not sure. There are driving challenges where the car is supposed to complete 2 laps to the track with different levels of difficulty. There is the challenge D1 where there is no obstacle there is no signs, just the car has to complete 2 laps as fast as possible. So time here is an important issue. The only thing is that cannot, of course, go out of the track and has to stop in the crosswalk in a given position. There is cannot stop on top of the crosswalk, cannot stop before crosswalk. There is a region where the car has to stop. Then it is a D2 challenge where, in addition to the previous one, the signs in the gantry display a sign. The car has to identify the sign and follow what the sign says. Can be a stop, can be a go to left or go to right, depending on the direction, or can go ahead. Okay. Then the three in plus of D2, there are obstacles in the some of the lanes, so the car has to identify them and overtake them. And finally, in the D4, there is additional area that is in code work. And so,
okay. Question: is there a case of moving obstacles, or you have?
No, you cannot move the obstacles.
It would be interesting.
Move, just.
I know it can be hard to replicate in this scenario, but I was figuring that in those cases the vehicle would have to predict by keeping in mind the speed at which the obstacles were moving. Right?
Yes, we already think about that, but we don't have that good competitors in order to put the rules with that kind of things. Okay, In general, we have most of teams, for instance, there only one team in the past that solved the problem with the whole block area. So we have to prepare the rules according to the kind of competitors we have. So that's a good idea. There are, I think in Germany, a competition where they have the kind of the car go to a cross and then a moving car. The other day had to wait until the moving car passed before turning to left or to right. Okay. In this case, the only thing is that the location of the obstacles is not known in advance. Okay, so the car is put in the starting position, and then after that, the places where the obstacles are put.
And do the obstacles all look the same?
Eh?
Do the obstacles look the same? Are they always kind of like pins?
In this moment, no. The obstacles in this case are black, these green boxes. This is this 16 by 16 that just make one of the lanes impossible to drive. And normally what we do is put one there and one here in order the car has always to overtake one of the obstacles, depending on the direction it takes. Okay. Here the point is that the cones are put in some position that it's not possible to follow the right line, the white lines, because here normal way of driving is just follow the white lines. Here they are put in some, not like that. Here it's easy to solve the problem. Just follow the white line. This puts in some way that the car need to forget about white lines, just follow the cones in order to make the movement. Okay.
So about parking lots, do you verify
the
parking lots?
Yeah.
If there is an obstacle, do you verify if the participant has...
I'm talking about that in next slide. Okay. So this is what we call driving challenges. Okay. And the competition is done in some way. There are different rounds. There are 4 rounds during the 3 days, and typically the teams that compete choose which one of the challenges they can face. Of course, it only can go to D1 after complete the D2 after complete D1 and go on. Okay, so that's the main idea. In the past, there was different. Each round has a different challenge. Sometimes what happens is that people that don't solve the first round cannot solve the others. And so nowadays we allow people to try the second day to solve the challenge of the first day. So people can just try to do something working that's good in competition. Well, in the parking challenge there are 4 challenges as well. 2 relating the parallel lane, one with obstacles, the other without obstacles. So with obstacles means that there are 2 obstacles. And so the car has to park between them, and the distance between the boxes, the obstacles, is twice the length of the hobo. Because what happens in the first edition of this is that the ones with a very small car just stop in front because they are like smarts. And so now it's mandatory to park parallel to the lane, and the length is twice the distance, the size of the hobo. Okay, so this is the 2 P1 and P2 challenges. The B1 and B2, the idea is to park there in the bay area. Again, one of them without any obstacle, and according to the rules, the position of the P area is not known in advance. What happens is that in general they are, because we just put the lines there and that's not easy just to move it. So, but anyway, in the B2, one of the places not known in advance is occupied by a box, and so the car has to understand that and choose the other one.
Let's say that someone hard-coded the
you can do it, no problem. We allow it.
Okay. And
the parking, you're not winning only with parking competition. So you can do that. Of course, you can do that for the one without obstacles.
Yeah, yeah.
For the one with obstacles, you have to understand which one you can try.
You can be lucky.
It's 50-50, so can be lucky and then you can try. Okay, but well, there is also a last challenge that we call vertical sign detection challenge. The idea is that this kind of signs, vertical signs, are put in the track, right side or left side. They are a set of 12 signs belonging to 3 different categories, and 6 of them are placed in the track, and so the car has to can do 2 laps to the track without time. The time is don't care, and they have to identify which are the signs. There are a score for identifying the category and a score for identifying the correct sign. Okay. The problem with time is not taken because each team has 10 minutes to do what they want. And so if you spend all the time just identifying vertical signs, have no time to the other challenge. So don't care about the time in the kind of competition. Okay, so that's the idea. Well, once I have introduced the competition itself, now let's introduce our car that competes in this competition. The car is here. You can see the sign. The car is it's a tricycle. So there is a driving wheel in the rear. Here you cannot see, just a little bit of the wheel that is there, driving by a motor. There is 2 steering wheels in front with an Ackerman type of steering system. Okay, so it's here that if you just move the servo motor, it controls the position. It is done in such a way that when you move to the left, the amount of the angle of the inner wheel is different from the other one, in order to avoid as much as possible slipping of the car. Okay, there is a camera. It's a Kinect camera nowadays. We decided to use a single camera for that. Most of the teams, I think all of them, except we, use 2 or 3 cameras. In general, they try to have a camera for the signs, both the vertical signs and the gantry signs, and 2 cameras for the delimiting lines, because in general you don't have field view enough to cover the whole track. So here we decide, well, this is a project for the students. This is done mostly, or well, mostly. I do some supervising issue only, so this is students' work. So we decided this in terms of teaching purposes. It's better to have a single camera and try to use it for everything. So the idea at the beginning, well, when I drive my car, I look at the road and I look at the sign, I look at the road and I do that. In this case, if I look at the sign, I cannot see the road. If I look at the road, I cannot see the sign. So there is a difficulty on that. What we do nowadays, when we stop every time at the crosswalk, look at the sign and decide it over. But the idea is to do that before. So if some of you want to join the project and develop that part, that's the main idea, is try to understand, try to drive in some way without looking at the road, and enough time for identifying the sign in the entry, and then again deciding, should I stop? Because the idea is simple. If time counts, if the sign is green, why don't stop? Now we have to, because we don't have information about the signs. Okay. Then there is also a headlight in the car, because it can exist at I think it was, it is not sure. What is that? Oh, here. can be a tunnel on the, and so we need lights because otherwise you not see the radiating lines in the in the track. Okay, so our decision for building the robot is to have 2 layers for the control part. There is a low-level layer made of microcontrollers. You can see in between. So there is a set of microcontroller boards connected in a CAN network, and that are one of them is a gateway that connected to a laptop where the high-level software runs. Okay, that's our decision. It's the same for all of our robots. The Gambada soccer player has the same approach, a set of microcontrollers boards, each one with a specific function, for instance, driving the tracking wheel, preparing the decision. This camera, of course, since I need to move it, it has a pan and tilt system, so I can just tilt the camera or pan. So the idea is to, so I have to drive also the 2 servers. That's it. Okay, and so in the laptop, the connection between the low level was promoted. Actually, it was important than that. So, ele não tem trabalho. Não, tem uma coisa qualquer que se põe aí e ele trava. Foi mesmo. Não, ok. Não, já não. Assim. Assim. Nós no laboratório temos as coisinhas assim. Por acaso tenho, não, o que eu tenho no laboratório e que fui trazer é um daqueles pratos rotativos de suporte da panela de fondue. Portanto, okay, but here what we have, so you have to have. Okay, so talking about. So the low level is controlling the pan and tilt, is controlling the lights, controlling the servo motor, that the steering system, is controlling the driving system. Okay, so you can see there the set of elements. Well, this is what I'm showing. Now you see there is a set set of, they are connected in the CAN bus, and it's known from the automobile industry, and the high-level control layer that runs in the laptop was developed on top of ROS. I don't know if you know what ROS stands for. ROS is a Hobo operating system. Actually, it's a middleware on top of Linux that allows, has a publish-subscriber paradigm of programming. It means that I can easily construct a modular approach for the software. And also there is a lot of modules already developed in the community, so we can reuse a set of things instead of develop everything from scratch. That's an idea. We have also developed a realistic simulator. I can show you later on. That is support also in ROS and in Gazebo, which is a simulation environment for robotics problems. Okay. Well, since I was asked to bring some discussion to here, so I decided to put one slide with the main modules of our high-level software. And so I don't have then a slide for each one of them. The idea is just to discuss which one you want. As I say, the approach is a publish-subscriber paradigm which is defined by ROS. What ROS stands for means I can develop nodes. What in the ROS terminology is named a node. It's actually a program. It's a process in terms of the computer or a thread. And then that process can subscribe a topic, which is a recipient where I can store messages. And then my nodes can be either subscribers or publishers. So I can, when I construct a node, I don't care about who is producing the information. I know that information is there in that topic. I just subscribe it. I produce some output and publish it in another topic. So any other node can just subscribe that node and then create the chain or the network of processing that I need to. Okay, so we have in the different states of the project, we have a node or a module. It's not it can be more than one node actually, but I look at it as a single module. There is a module that is the interface to the low level. So for instance, I want the car to drive at 1 meter per second, and so that module do all the calculations required in order to issue the right commands to our low level. And it's also what we call data reckoning. So by the motor that drives this wheel has an encoder, and so based on that, the counting of that encoder, and based on position of the servo that controls the direction, the steering of the system, I can update the position of the robot based just on that information. So that information can be used in high level in order to do some kind of calculation required. There is of course the image acquisition for Kinet. This is kind of module that we don't do nothing, just use ones that are available in the community. There is also I don't talk about that because there is a laser rangefinder here. It was now go to Italy because another project, so that's totally for me. But I think in the pictures there is the Alcuyo rangefinder because and so it's not there. And so we also have a module to acquire information from the laser. Already, this module, as the previous one, was already done in community, so just use it. Then we have some image processing depending on the other modules. There is we decided to, in order to drive, to follow two different approaches. When we are, for instance, in the middle of a track, we just need to follow the lane. Okay, we actually don't care when exactly I am in the track. It's more important to know how far am I from the center of the track and what is my orientation. So we have what we call a lane pose estimator. So we try to estimate where the robot is in relation to the line. And based on that, we control the movement of the robot. But also we need to know, am I close to the crosswalk? Am I close to the tunnel? And so we also have a module for estimating the real pose of the robot in relation to the wall, means to the track. So we have a frame system center in crosswalk, and so every moment I know where the robot. I have an estimation actually because I'm noisy. I have an estimation where the robot is at a given point in the track. This is important not only for the particles, for instance, for the obstacles, for the parking, etc. It's important to know this position. We also have a model for obstacle detection and localization. Not enough to identify that there is an obstacle there. It's important to know where it is. For instance, an obstacle cannot be an obstacle if the obstacle is in the other lane as the one where the robot is moving. No problem. It's only a problem if it is the same lane that the car is following at a given moment. So we have to identify where it is which lane is the obstacle actually. Then all this is used to have an algorithm for navigate, what to do, when use the line or the line pose to navigate, when to use the wall pose, etc. What to do in order to overtake an obstacle. So this is the navigation module. Of course, when the robot is at the gantry, it has to identify the sign that is there. Kind of template matching or other approach in order to do that. Also, in relation to the signs, they are in the vertical signs. And finally, we need some strategy to overcome the different challenges. In addition to this, we also decided to, for instance, can the robot navigate in an unknown map? That map there is known in advance. the rules for competition. Says that is the track. Dimensions are there. Everything is there. So I can prepare my car to compete in a scenario that is known in advance. Only the obstacles are not known. But it could be interesting to just use, for instance, a joystick. That's why the remote control. And then put the robot moving in the environment. Is acquiring information about where are the limiting lines. And then at the end, we can construct the track. Okay, draw the map where it's moving. We do that when we have a mapping. Because this area we are working with, so the project is also for that. No? Not only to compete, but also at all is a project for students to test different approaches. Well, based on this amount of modules, I decided to refer one or two. Then you, if you wish, we can discuss the others. It's up to you. Well, one of them, which is important, is we call the web reckoning. Not the interface. This is just translating information from one language to the other. Here the idea is to use the information from the driving wheel on the odometer and the position of the steering wheels. Not the steering wheels, but actually we make calculations based in a virtual wheel that we believe are in the middle between both. And that virtual wheel is used with some telemetry just as to Sim, falta uma mínima. Okay. One important is how do we decide about the position of the robot in the lane. What we do is an approach based in histograms filters. This is the original image taken by the camera. We first make an image correction in order to, based on the position of the camera, we just eliminate the reflective error. So we have the image in the right. Then we apply, since this is getting too much information, we decide just to crop the image. Then we apply a kind filter to extract the component. Then we apply a transform to identify lines. Then we select some of that lines, and we get this. And so, based on these line segments, we can decide both about where the car is in track. Since we don't know where these lines belong to, what we have is some kind of this. If you see here, we have two lanes, and then there is one to the right, that is the parking lane. But if the car is moving in the opposite direction, actually I have an initial line to the left, and then there is the places to the right of that lane and to the left of that. So we decide in the algorithm to consider 6 regions, and then each one of these lines actually builds a Gaussian. We add all these Gaussians, and we have this kind of filter. Then we filter this one with the previous one. We will make data fusion, so integration this with the previous measurements. We have a representation where the car is at the given moment. That's the idea. We have a histogram for the relation positioner and for the orientation. Okay. Well, in terms of the global, we use a particle filter. In this picture, each one of these arrows is a possible position for the robot and orientation. And so what we do at each step is that based in the odometry data, we advance these arrows, and then based in the measurement, we weight them, and based on the weight, we resample and have a new distribution. And so hopefully they converge to the real position of the robot. That's the main idea. This is a video actually. Maybe I can. No. Very. and then as car is moving, you know that the particles are going narrow, and then most of them now are in the almost right position of the car. Okay.
For this to work, you need to know the road beforehand, right? You need to.
Yes, we need a map. Or either we have the map in advance, but in this case it's not. Actually, this map wasn't acquired. What we do, we can do mapping. So I can use the joystick in order to drive, make acquisition, and then based on that, I can build the map, and then afterwards use that map to navigate.
You can use that method on competition or not? You can use the joystick part and.
No, joystick is just for is for two things. One to do this, just to acquire information from sensors, or in order to evaluate the localization system, I can force using joystick the car to move from the lanes in order to see if the localization system is working nice. That's good. But in competitions you cannot. Officially. But you cannot, it's impossible. If you use joystick, I assure you, this car already moves in one competition 2.5 meters per second. You cannot do that with joystick. Okay, let's see. What else? Então, o que é que se passou aqui? Não. Ok.
Sei que eu não quero puxar o da
Okay. Well, this is the way we drive. Actually, we have an hybrid approach. For instance, from here to there, we are using the lane information just to drive. Then, in the vicinity of the crosswalk, we decide to use a global approach. And then, as soon as we cross the crosswalk, we again get the line information to drive. That's okay. And so, well, this is just the main cycle. Is based on a decision state machine, and I have two videos if you want to see them. They are interesting, and I can tell you why. At first, this is the first time Rota, not this version but the previous version of Rota, participated in a competition. It was in 2006 in Guimarães, and the old software, the car itself was concluded the day before we go to Guimarães as a presentation of Bruno Pires, and then all the software was done there during 4 nights, 4 days, no, mornings, afternoons and nights actually, and so. But it's interesting because if you are comparing how they drive into approach. In this case here, we decide to use just global navigation. So we're using particle filter, and then based on that information on the global localization that is given by that algorithm to drive based on this. And I think it's interesting to see how. So I'm starting with this one. No what? No what? Alt. Oops. Goes low.
It's in laptop, yeah.
Yeah.
Just okay.
You can put laptop here.
No. Maybe.
Okay.
Okay. This is based on particle filter and on localization and driving based on this. There is a lot of because of the particles. From step to step, I have to choose which position to use to navigate, And normally what we use is the centroid based on the more dense part of the particle. You see here, this is interesting because people say it solves the. There is no software to avoid obstacles. Simple lucky.
It's a feature.
That's why Obico is going there in order to stop the car, and I told him no, because I see it's turning left, just lucky. Okay. So okay. Well, there is a penalty here because suppose the car has to stop in the. Sorry. Someone forgets to stop the car. The car has to stop in this white line. Okay, so but anyway, it's better not to stop after before that. Well, let's see the other movie. So this one was in Skonskino. I told you that okay. This one was in 2014. So now I'm showing one in 2006 with a quite simple software. What we have done, simple, based on image, we draw a line to the right, follow the line, should transition from black to white, and use that information to the right. It's just 4 days, all we can do in that time. So, better that way. So, 2006. Oh, okay. Sorry. Perfect, né? We are just measuring the distance to this line and keep a given distance. Only that, with a single line in the image. No, the point is that, well, if you just want to compete, there are simple approaches you can follow. If you want to use this as a kind of research work, that's it. So what we decided is, well, if you want to compete, this is not a good idea. It's good in order to test solutions to solve the problems using different approaches. Okay. Okay, I think it's all. I'm not sure. Yes, it's all.
I think we have time for a couple of questions, or rather, we don't have time, but let's try it anyway.
Okay, I put the slide with all the models. So.
Just about 1 or 2.
Yeah, you have the Kinect from Stick. You had supposedly the lidar, the laser range finder. They provide certain sense, redundant information.
Yes.
Do some kind of sensor fusion or just process them separately?
At this moment, we are not doing that. We are using the laser for the obstacles and for the this year I have 2 projects, two final dissertations involving machine learning. One to use the information from the laser in order to identify where is the entry, where are the cones of the roadwork area, and where is the obstacles, and try from learn how to use them in order to survive the obstacles. And there is another project that is trying to use just the image to drive in the lane. So put the car trying to drive just from sketch, trying to know. We do some work. You notice that one or the other saw that work. That was how to use machine learning in order for and using the image, how to identify where the crosswalk is, and then try to use that information in order to, for instance, use it also to improve localization. Because where the crosswalk. So if you have some question about that, we know it's there. It's one that doesn't work. But the idea is now just we put Okuyu there because first we have one. So we try to use it. And then in the future we are trying, yes, to do some kind of data fusion, but right now only for different purposes. Okay. For instance, we are using the dash camera in order to decide where, with the color image, we have what are the transitions from black to white, so where are the derivative lines. Fusing this information with that, we can decide where are in the wall, because we have position. So we are using that in order to identify the position in the map correctly. Okay.
All right, so let's thank the speaker for an amazing presentation.
If there are volunteers to work on this,
yes,
it is always there.
Before we go, I'd just like to a quick.
Not only me.
It's always technical problem.
There we go. Okay.
Okay, too many beers.
But
okay.
Just 5 more minutes of your time. Just a quick overview of the event happening on this place in the next few months. Just take a look at it. We'll share the presentation with you. You can also see it later. This one, but also 4 more. Lisbon and Porto, everywhere. This data science is happening everywhere in Portugal right now. Also, more data science Portugal events happening in this order, I think. Maybe not. The next one should be in Porto, but then Braga, Coimbra, Lisbon, Aveiro in sometime soon as well. So stay tuned for that. Just follow the meetup or the Facebook or Twitter, everywhere where we are. Stay tuned for that. Slack, obviously. And just as I promised, we have a book to give to the lucky.
If you can get it on the screen, please use it.
Yes. Just go to that address or scan this. Yeah, this is kind of in the way of scanning.
Yeah. I can do it.
The prize is the book
and the prize is not
the book and the beer. Yeah.
While you're answering the survey, we have some fascinating.
João Gama.
Oh yes. Okay, so first let's thank João Gama, Professor João Gama, for providing us with this book, Extração de Conhecimento de Dados. So this is Portuguese. One or two people here cannot read that. So just answer the survey. At the end, you will have an option to give out your name. We don't use that to track you. It's just so we can give you an award later. Right.
So João Gama is a professor at FEP.
Yes.
Okay.
Yes, very famous guy in this field.
I'm serious.
Yes. Also a previous presenter of a meetup.
Yeah.
Sorry. Yes. Exactly. All right. So we also have some cool news to show you.
1 to 3, and the don't care is closer to 3 or to 1.
One is low priority and the 3 is high priority.
We discussed about that.
It's a process.
We are engineers, so it's data.
So while you guys are answering, we wanted to share with you that the Science Portugal is going to be a association.
Yeah, tomorrow.
Tomorrow, is it going to be tomorrow an association or?
Tomorrow, yeah.
Tomorrow we're going to announce it's going to be, okay, tomorrow is going to be the signing of the papers thing, something that's going to make it official. It's going to be a non-profit association.
Yeah.
Want to say more about this?
No.
Okay, that's just it. So that the science is going.
In the future, you will know.
Going.
Some news.
So stay tuned for that as well. You guys managed to go to the quiz? Just answer. You have time.
Are we there yet? Are we there yet?
I still see people.
Are we there yet? Are we there yet? No.
Quem deveria ser mais?
Já não tem tempo. Não. De conduzir no simulador? Dava, eu trouxe joystick. No carro não. No carro não tem de bateria. Mas no simulador dá para conduzir. Enquanto a malta.
Let's just give it a couple more minutes, and I have no guarantee that it's going to work.
Yeah.
This is like a live test, like proper men do. We're testing live.
It's amazing you see no tracking and you ask my name again.
Yes. You can answer it. Yeah. Just say 1, 2, 3, 4.
We are compliant for GDPR.
No, we're not.
No.
Don't make promises we can keep.
Yeah.
We are aware. It's not a record, so yeah.
You cannot record our data on May 15.
I can hear you. Next time, you still have a couple of months to take care about that. Cool?
Sure.
Sure? Okay, let's see if this works. If it doesn't, I'm not a software developer. I'm just. Okay, this is.
And the winner is João Souza.
Okay, who's this? RJJ.
Hey, hey, nice.
E não vou cerveja. Voltar a.
Hey guys, thanks. Yes, we're done. Thank you very much for coming, and stay tuned for the next events. Right? And thanks to speakers again.
Tem que já teria esse cartão, não? Tinha em cima do portátil, alguém me olhar para vir para aqui e nem sei onde é que eu deixei. Eu vou arrumar, mas depois vou para
Agora é fácil pôr